This is the world's tallest, steepest, fastest wooden roller coaster. I forget where this is. Jersey? Someone from last class had gone on it, and I'm impressed. Okay? So, I need a volunteer to push play when I say push play on the back, because now we're recording for the video. So I'll hear the sound on my end, but you need to hear the sound too. We'll see. So her question is, what does the roller coaster have to do with this? We can answer that. Somebody can read my objective for today on the far right. Who can read that nice and loud? Teacher voice. Who's the loudest person here? Me. Lewis, can you read it from all the way back there? It's coming. Yes, just not right this second. I need the objective read super loud. Over here. What does it say? That. Loud, loud. Students will. Thank you. So, raise your hand if you remember slope from last year. You all, come on, everybody. Yes, that would count. Slope intercept form, slope, points, all of this great stuff. Let's watch this first. Because clearly we're going to do some calculations with it. But let's see what it is first. So, Lewis, when I say 1, we're both going to hit play at the same time. Okay? 3, 2, 1. The track is metal, but everything that's built from under the track down is wood. Absolutely not. Like right there, I'd be questioning my sanity. That's insane. Are you all noticing they're still going up? That's a little too much. Still not even halfway up right now.
Wait, it is still going up. That's crazy.
Notice it's still going up.
It'd be crazy if it stopped and went backwards. Yeah, what if it went backwards? They thought they were going down. You would have been at Me too. Oh, I like about touch the sky. But yeah. Stop. Oh my goodness. I learned that. I would not keep my phone out. That's a GoPro. No, look at it. Sorry. Is he holding it?
From the, it looks blue, but that's wood all the way down underneath.
You mean the beam? That looks fun. That'd be crazy. That'd be crazy if the beam is going. The boulder that is like compound, it's like shaky, but this is like a smooth ride. This still high up. But it's fast. This tip over. Done. I want to go on that with Troy.
Okay.
You write me out.
Okay.
Right now.
Who, you think who's on this? For what?
Like when I'm through that kind of time. I really do.
All right, who'll go on this? Who's lying? Okay. So. No. Nope, not happening. I value my life. So, let's talk about this. My question to you is the climb steeper or the drop steeper, and how do you know? Yeah, but what if I can't just look at it? The climb is steeper?
Yeah.
Who votes the climb is steeper?
Climb is longer, the drop is steeper.
Who votes that the climb is steeper? I mean, drop steeper. Can we use math to figure that out? Of course we can. Notice what it says at the bottom of the page. What does it say? Who remembers how to find rate of change? Make all your ninth grade teachers proud. You forgot? What? How do we calculate M? We're going to jump into it in notes in a second, but let's see if we can refresh our brains. How do we calculate slope? Try again. What is y equals mx plus b? What's that called? That's a form. That is slope-intercept form. That is not how we calculate slope. That's not part of the formula. Try again. M equals? No. Mx plus b was slope-intercept form. How about, let me see if I can trigger your memory. How about this?
No? Wait. That's the Wait, did it do X?
Oh, hey. Yeah. Thank you. Yeah. Great. So now that we established we have knowledge from last year, it's very exciting. What two ordered pairs are we going to use for the climb? But I need two actual values. 0, 0. It's on your paper. All right, let's calculate the slope. Use those 2 points. Do it with me. Let's go. M equals 0 and 5. I need 0 minus. So I like stacking these points because it kind of lines up my y values. So if we want to subtract, it's going to be 0 minus 165 in the numerator divided by 0. What do you mean 0, 165? 0 minus 165. What is 0 minus 165 in the numerator? Divide by? Good. Okay, so we now have the rate of change for the climb. What two ordered pairs are we going to use for the drop? 247 comma 0. Make sure you're doing this with me. 247 comma 0 and
the top one.
What was that top? Okay, on your own, find the rate of change for the drop, please. Calculating slope. No one has lost cause. Show the work.
No, she just said show the work.
David. What are we subtracting in the top?
247.
Yeah, be careful. I hear some X values out there. These are my Y values. Oh. So what are we subtracting in the numerator? Let's all try that again. Numerator, top, in the top. Okay. So if I do 0 minus 165 in the numerator. All right, there we go. Now we're on the same page. Let's find that. What is that? And in the denominator, 247 minus 165?
Equals 1.
So I'm looking for the denominator. You're saying it's 142 in the denominator? I'm asking. 247 minus 165. We are all very competent 10th graders. Tell me if that's 82? Folks, let's all agree on 247 minus 165. 82. What decimal do we get? 2.01. I almost agree with that answer. Negative 2.01. No, let's keep the decimal. Thanks. Yes.
When you put 0 minus 165 divided by 247 minus 165. Why don't you put 0 with 247?
So his question was, why is 0 not down here? So in the numerator, do you agree we're subtracting the y values?
Mm-hmm.
So that would be 0 minus 165. What are my x values going to be?
Wait, 247. So it's always the right side? That's the bottom.
Good question. So the question was, is it always the right side? If we look at how we write ordered pairs, what's the answer to your question? If my ordered pairs are written properly, let's make it match. It will always be the right side points if you stack them like that. Okay, our brains are warmed up. We had many oh yeah moments. So we are ready for some notes. Yes. So remember, we are building our own textbook.
So how do we know which side is steeper?
We didn't actually answer that question. How do I know which side is steeper? Ooh. Yeah, but how do I know based on my calculations? The negative makes it steeper? Well, let's talk positive and negative. Positive just tells me that I am going how? Left to right. Negative is going underground? This roller coaster is above ground, but I had a negative slope. Say it one more time. Okay, so we have some good thoughts here, but let's all get on the same page. If I have a positive slope, and we'll talk about this more formally in a second, if I have a positive slope here, it's positive 1 because left to right, what are we doing? How are you going? Up. And then here for the drop, how are we going? Down. So positive and negative, the fact that this is positive here just means you are going up. Here, a negative slope meant you are going down. So positive and negative really is not affecting my steepness. So if I just look at the number, just look at it's called absolute value, but just look at the number, 1 compared to 2, which is bigger? 2. So which is mathematically steeper? Which is the drop or the rise? The drop. Okay, keep all of those thoughts in mind because we're going to formalize some of what we just talked about right now. Now, this is not Algebra 2. Let me say that again. Everything on this page you learned when? Last year. So if we're moving at a decent pace, it's because this is what's called prior knowledge, meaning you already learned it. But it's been about a year, so we're going to take one day and bring it all back. Okay? Slope of a non-vertical line. Non-vertical. What does vertical look like?
Straight up.
Straight up. So this is vertical. We're saying non-vertical, so not straight up and down, is the ratio of what to what? What does it say? Ratio of?
Vertical change.
Vertical change. Reading for information. Vertical change to horizontal change. Raise your hand if you saw that triangle last year ever. Anyone? One? Some teachers used it, some didn't. In math, that triangle means change. And from now on, we will use it to represent that word. So slope is a ratio of vertical change to horizontal change. What letter represents slope? M. How many points do you need? 2. Does it matter which 2 points on a line you use? No. It does not. We'll talk about constant rate of change in a little bit. But last year you did learn and you proved to yourself that you could choose any 2 points on a line. The slope will come out the same if you're working on that line. To tell the difference between 2 points, instead of just writing x, y, we write x1, comma, y1 for one of the points. And what do we call the second point? Good. To calculate slope, I use the formula. What? What's this formula? I'm listening. We just wrote it on our warm-up. Y2 minus Y1 divided by, good job for saying divided by and not over. Let's not use that word over. When we're talking about division, good job, use divided by. Keep going.
X2.
Yes.
Minus X, minus Y2. No, X2. X1. X1.
Okay. From last year, does anyone remember another way we could choose to write this? Did we have to start with Y2?
No. It can be X1, Y1.
Could it be Y1 first? Could I do this? We're going to prove it to ourselves in a second. But if I start with Y1 in the top, what do I have to start with in the bottom?
X1. Actually, you can. You know how you said about ignore the negative? How big the number is?
That comes when we talk about steepness, so keep that in mind. Here, the negatives do matter. So let's prove to ourselves that we can use both equations. Again, my recommendation, when we're given 2 points, let's stack them, one on top of the other. Because then, who asked if it's always on the right side? That was Lewis. So if I stack my points, then yes, my y values will be on the right side. So how are we going to calculate slope? Tell me what should I write? Tell me what to write. Gladys?
It don't matter which one we use, like Y2.
Go for it. You commit. Tell me what to do.
One.
I don't know if I see any commas up here.
Minus 1.
Okay, 5 minus 1. Good. Keep going, Gladys.
Divided by
-2
minus 2.
Great job. Everyone, 5 minus 1 in the top. Careful. 5 minus 1? 4. It's all good. In the denominator, 5 or negative 5? Negative 5. Typically, do we leave negatives in the denominators? Nope. Let's bring it up. So I get negative 4/5. Now, someone had mentioned they weren't sure how these are the same, that I can have either of these equations. We're going to prove it to ourselves right now. So we could have started, instead of starting with 5, what could I have started with? I could start with 1. So if, watch where I'm pointing. If I do, watch the screen, watching. If I do 1 minus 5, then in the denominator, I need to do 2.
Negative 3.
No.
Is that right?
No.
Would it be negative when it turns to positive?
Yes, yes. So we have to remember this negative sign is built into my formula. So if I'm actually going to be subtracting a negative, it is going to be a double negative. So 2 minus a negative 3.
So when you flip it, it turns into a negative. So when it's negative, it's a positive.
2 negatives side by side. Subtracting a negative turns into a positive. So it will be 4. Negative 4 divided by positive 5. Did we get the same answer? Yes. Question.
Wait, so
A personal preference. The question was, why didn't we do this first?
every time you flip it,
I find that some people really like starting with one order versus the other. They're both completely correct. Shemar, you good? Do you need to pass the nurse? Okay, let's sit up nice and tall.
every time you flip it,
Every time we flip it,
it switches sign.
it switches the sign. What do you mean by that?
Number.
Can you make that more of a complete sentence for me?
Yeah, negative. Never mind.
Are you saying here the negative was in the denominator and we brought it up? And then here,
The negative 3 with the minus, like 2 minus negative 3.
so if I'm subtracting a negative, that will always turn into a positive. Yes. Question, Faith. David, sit up.
If we decided to do it the second way, does that mean all the time the smaller number will go in front of the bigger number, or will it?
When you say in front, it depends on the ordered pairs.
So
So it doesn't depend on that.
So that
Nope.
we only put the parentheses if it's a negative?
Correct. If we're substituting in a negative, we use parentheses. Okay, let's prove to ourselves that we're right. It says after you calculate the slope, graph the 2 points. Let's remember how to graph 2 points. I'm trying to graph negative 3, 5. Where should I start? Where do I start from? Do I start counting from right here? No. Very good. I start from the origin. So I'm at the origin, 0, 0, and how do I move? Horizontal. So horizontal could be left or right. Are you saying I should go left or I should go right? I am on the x-axis. You're both right. I'm on the x-axis, which is a horizontal movement. My question still stands. I'm trying to plot negative 3, 5. So is that left 3, up 1, 2, 3, 4, 5. There we go. That's negative 3, 5. I come back to the origin. Right 2, up 1. Good job. So let's graph that line. Your IDs make fantastic rulers. We're not doing squiggly lines here, people. So find that ID. Hopefully it's somewhere in your backpack or at home. Get it here for next week, or get yourself a small little ruler, or take a piece of paper, fold it in 4s. That makes a straight edge of some kind. Edge of a folder. Now we need to check. How do I check if my calculation for slope is correct? Jeffrey. Count the points in between. Which point are you saying I should start at?
Start at negative 3, 5.
Start at negative 3, 5. Down 1, 2, 3, 4.
And then go. That'd be for the numerator. And then
Yes.
go 5.
1, 2, 3, 4, 5. 5 right?
And that matches the fraction.
Matches my answer. Yes. Why did I put arrows if there's 2 dots? Great question. So we are not limiting this to a segment. We are saying that these 2 points lie on a line. So automatically when I graph, I need to put arrows on both ends.
Yes. You keep going. You still have the fraction.
Yes. So think back to the last unit. When I had domain restrictions, that's maybe when I had a segment. But are anywhere here, are we restricting this line? No. Yes. Great question. Vertical change always first. So if I started at this point, that was down 4, right 5, which matches this, correct? Down 4, right 5. But what if I started at this point? So start with me here. How would you count? 1, 2, 3, 4. Which way? Up. 1, 2, 3, 4. That's up 4. But now how do I go? Left. 1, 2, 3, 4, 5. Nope. Just 5. So take a look at what we just graphed in green. Up 4, left 5. So that's proving to us it doesn't matter what we do first. Right? Very exciting. So the whole point of this example is that you get to choose your order. Nice job. Refresher, positive, negative, 0, and undefined. Positive, left to right means you're going how? Up, left to right. Negative, left to right, going down. 0 slope, what kind of line is that? Horizontal. And undefined, vertical. Tomorrow, unless you need to pass to the nurse, we're going to sit up nice and tall. 2-second refresher. Tell me again. Positive. Up. Which way, though? Which way do we always look? What to what? Left to right. Up. Good. Left to right. Down is negative. What's another word for down? Decreasing. Decreasing down. What's another word for up? Increasing. No song lyrics right now. Save that for later. All right. Now that we have remembered what's positive, negative, zero, and undefined, let's classify lines. So without graphing, notice there's no graph here. Tell whether the line is increasing, decreasing, horizontal, or vertical. How are we going to figure that out? What formula? What's that thing we just did? What's that called?
The slope.
Calculate the slope using what they're talking about. So if it helps, off to the side, let's rewrite our formula. What's the formula for slope?
y2 minus y1 divided by x2 minus x1.
Good. Let's use that for A and then B, and we'll compare our answers. Go for it. So before you can tell me, you have to back up your answer with math. With math. Prove to yourselves using that calculation. You can check in with a neighbor on your answer. Not so sure about that one. Yes, do both. Because we're going to talk about both. What did you guys get for the first one? Negative 2 divided by 2? 2 divided by 2? Negative 10 divided by 2? 5? Let's establish what the formula will look like. What are you subtracting in the numerator?
Negative 4 minus parentheses negative 6. Which means divided by 3.
So let's just pause right here. How did some people get a negative 10 by accident?
Because they forgot to put the parentheses.
Not only did they forget the parentheses, but did they put the negative, the second name? No. So this is not a difficult formula, but check out what happens if we're just wrong even with one sign. Yes, Emily? They do. What do we have in the denominator, though, first? So if I do negative 4 minus negative 6, I do 3 minus 1 in the denominator. What is negative 4 minus negative 6? Positive 2 divided by 2 equals 1. Careful, careful. It is positive 1. So is this a increasing line, decreasing line?
Increasing.
How do you know it's increasing? It's a positive value. Exactly. So we can do, you started with negative 6?
No, I did 3 minus negative 4 on top, and then 1 minus negative 6. Like the same numbers.
Pure coincidence.
And then I got the same.
That was magic right there. Okay? So that's pure coincidence. We cannot do x1 minus y. No good. Because remember, what we're actually doing with math, you realize how we counted up and down first? When you do that subtraction of the y values, you're actually doing the math behind counting up and down, and then left or right. Can you count up and down and left and right at the same time? No. So we have to do our y subtraction first, divided by our x subtraction. That is mirroring counting up and down, counting left and right. Right? It is not. Okay. Increasing, because it is a positive slope. What do we get for B? Okay, go for it. If you're done, check with who's next to you, if they're done. Let's not shout out so everybody has a chance to do their work. Yes. Kind of stuck on B? Talk to me about what you did so far. Oh, Emily will help you. Go for it. Always. What do we get in the top? Davion.
I got negative 6.
So I'm thinking you did negative 1 minus 5?
Yes, I put in a calculator.
And then, well, let's not use a calculator for anything under 10, ever.
I know, I was just checking.
Good checking. Good job. But did you use a calculator to do it first? Good. So if I do negative 1 minus 5 in the top, what do I have to do in the bottom?
2 minus
Who got this?
Oh, I got it.
What is this?
What is the odd stuff is divided by?
Can we divide language? Can we divide by 0?
No.
Isn't that gonna be undefined?
Ding ding ding.
What?
Do we just keep it like that?
Ooh. It's a vertical line. Oh, undefined. Vertical.
Does anyone know how to show someone why you can't divide by 0? What if you had no calculator?
Well, nothing goes into 0. Everything goes.
So check this out. What's 10 divided by 2? And is 2 times 5 10? What might someone try to say 10 divided by 0 is? Is 0 times 10 10? No good. Fun fact for the day. Okay. Undefined, so we can't say positive or negative. It's neither. It's a vertical line. Comparing steepness of lines. What does steepness mean? What is this?
Like.
Someone explain to me what's steepness. What's steepness?
Like how is
What does that mean? What is steepness?
like how like low? Not low. It's like how sharp.
How crooked, how sharp something is?
Yeah, like I mean like. I'm like.
So if we're talking like walking on a hill, right? What does a steep hill look like?
Like really like it goes down.
Right, like this.
It's like.
But what else? If it's not steep, what is it? Right, more gradual. So we're talking like the rate at which something is increasing or decreasing, and it could be very steep, very flat, right? So keep that picture in mind. We need to tell which line is steeper, line 1 or line 2. How are we going to figure that out? Go for it. Find the slopes. Yes, you do, because you can. We're doing great. Let's keep going. Today is a great day to do math. It is. What'd you guys get for the first one? Should be done. Prior knowledge. -2? I got 2. I didn't write -7. So the other way would look like 3 minus 7 divided by 2 minus 4. We should still get a +2. So check your signs. So negative divided by negative is positive. Watch your signs. Line 2. Sounds like we might get a fraction for this one.
Yeah.
Did you guys do 2 minus 5 or 5 minus 2?
2 minus 5.
5 minus 1. If you're pulling 5 and 1, that's a y value, but what's this? Is this y?
No.
No. Only your y values. So let me ask again, 2 minus 5 or 5 minus 2? What's the vote? All right.
-1 minus 4.
Good job.
And then negative. So that's a 3/5.
Who got 3/5? 4? 5? Yes? Yes? Richie? 3/5? Is that a sure like a yes, yes, or like a sure like I have a question? I'll take a yes, yes. Good? Which is steeper?
2.
How do you know?
Because it's the smallest one.
It's the smallest one?
Yeah. I mean, no. It's the bigger number.
It is the bigger number. We established positive and negative has nothing to do with steepness in the roller coaster question. So we are truly just looking at the number. If I asked you to compare 2 and 8/5, 2?
That'll be 2 as well.
Good. So
Less than 2 because that's not a full. It's not a full number. Wait.
the fact that it's a whole number automatically makes it less steep. What? So he's right. 8/5 will come out to be 1 point something because he said 10 divided by 5 is 2. So 8 divided by 5 is smaller. But what if I gave you this?
That will be bigger. That'll be 3.
3 exactly?
No, it'll be 3. Oh, that's 16.
3 point something something. So just because something is a fraction does not necessarily mean that it may not be steeper. If that numerator is bigger, we should definitely divide and see.
If it has more than, if the numerator is bigger than the denominator, that's automatically a 1. So like if you have double the denominator as the numerator, then that's 2.
Yes, you're on the right track. We want to actually see what whole number point something we've got.
That one.
Yes, line 1 is steeper. Emily. Make sure we get a decimal for that fraction. Yes.
Oh yeah.
So the consensus is that if we have a fraction, get that decimal before you start comparing which one's steeper. Very good. Real world, very exciting. Lightning. Who likes lightning?
I don't like lightning.
I love lightning. It is very pretty. Now, this is in here as a notes example for you to look at on your own. Remember, we're building pieces of our textbook. The big picture of this is that we're going to be looking at constant rate of change, which we mentioned at the very beginning, and non-constant, but we're not looking at the non-constant today, just looking at constant. What does constant mean?
Keep going. Always.
Always is a good word for constant. So let's see. How do I get from 0 to 1? Add 1. How do I get from 1 to 2?
Add 1. So that's the add 1. Increase what add 1.
So are you adding 1 always using his word? Yes, you are. How about 0 to 5? Are you adding 5 always? Yes. So full circle. Do you remember way at the beginning when someone said, or we asked, does it matter which 2 points we use?
No.
It doesn't, because if I'm always adding 1 and I'm always adding 5, that's when it does not matter which 2 points we choose. Then it's going to matter. We're going to look at that next week. Okay? So they randomly chose 2, 10 and 5, 25, and they got their slope. But let's do our own real world. Our turn. Planes. The table shows the number of miles a plane traveled while in flight. Use the information to find the approximate rate of change in miles per minute. Which of these is X and which of these is Y? Okay, now we got to check, is this constant? How do I figure out if this is constant?
If it's going up by the same number.
So 30 to 60?
Yeah.
30.
60 to 90?
30.
Yep. 90 to 120? So I'm good there. I'm going up by 30 always. How about to get from 290 to 580? We can...
290.
How'd you figure that out?
Because I
Subtracted what?
580 take away 290.
Good. So now let's check 870 minus 580. Can you check that?
Yeah.
Let's check that. 870 minus 580.
290.
Still 290? And then how about 1160 minus 870? 290 again? Okay. So does it matter which 2 points you choose? No. What's our vote?
It's constant.
It is constant, but let's pick some points. What do you want to use?
60, 580.
That's one. He's picking this one. Give me another one.
120.
Let's calculate the slope. How am I going to do that? I'd be careful of just pulling. Let's actually write our ordered pairs. What are our ordered pairs?
How do you know which X is which Y?
And then 120 and 1000.
So in terms of knowing what's X, what's Y, think back to the last unit. Time will always be my independent variable, always, which is why we labeled that X. Once I know how much time, then I know the distance.
So 580.
Who's going to wrap this up? 580 minus
Minus one.
160? 1,160 divided by? Good. We're getting 1? What's 580 minus 1160? No guessing. Let's actually... Negative 580? 60 minus 120?
Negative 60.
Divide and we get? Jeffrey? Who's got the division? Let's get it. Let's get a decimal. 9.67?
I got 9.
Who got 9.67? Well, look, we round up 0.66. 0.67. That's fine. So we'll round up 0.67. So this is 9.67. What's my label? Careful. What is the Y measurement? There we go. Miles. Check it out. The numerator of this entire line of work references Y. And how is the Y values measured? Miles. How is X measured? Yeah. Miles per minute. Very good. Do the what part? We divided to get that decimal. Number 2 would be the same concept. So I'm gonna leave number 2 alone because guess what we're gonna do really fast? Guess. So excited. I'm so excited. Guess what? I'm so excited. Pop quiz. Little exit slip for us. Yay. Miss J is amazing. I know. It's like 4 questions. Yeah, the back page is homework. So this is a quick 5-question. Did we learn what we needed to learn today about slope? Show me all your knowledge. Oh, of course you have homework. It's the back page. But you should have time. So depending on how long it takes you to do the exit slip, you should have time to get started on the homework. Okay? Let's go. This will help us when we come back from the 4-day weekend and you get this back. You'll remember what we learned today because you'll get this back. Okay? Let's do no notes. No notes. So for people watching at home tonight, this is your homework, and we are taking a quick 5-question exit slip. Have a great weekend.